Hey everybody, this is our last lesson, 7.5, average rate of change. All right, so you're familiar with the concept of average rate of change. You started with talking about the slope formula. So if we were given 2 points, we wanted to find our slope. And the slope formula is y2 minus y1 over x2 minus x1, where our first point, our points are something like x1 comma y1 and x2 comma y2, okay? And we would plug those in and we'd find our stuff. So like here's an example of that. This would be like our x1 and our y1. This would be our x2 and our y2. And we'd plug that in, so we'd do y2 minus y1 all over x2 minus x1. And we'd simplify the top and the bottom. We'd get 2 over negative 4 or negative 1/2. And that is how we would find our slope from 2 points. Another way we could do that by just looking at a graph, we could go rise over run. And we did that, I think, when we did our absolute value functions to find what our slope is. So for when you have like a linear equation like y equals mx plus b, the slope is constant. But as you noticed in a lot of the functions we've been talking about, pretty much every other function, the slope is not constant. It's not linear. So like quadratics and exponentials and absolute value functions. Although absolute value functions have parts of the function that is linear, but if you did it between like this point and this point versus like this point and this point, the slopes would be different. So it depends on the points that you use. And it's the same for like quadratics. If we look at this quadratic, the slope between like 0, 0 and 1, 1 has a slope of 1. But if we go from 1, 1 to 2, 4, the slope here is 3. So the slope is not constant. And one of the reasons we're going to do this is so that we can kind of compare functions. So we're going to find absolute or not average rate of change for different types of functions. So if you have like a graph, you can choose like 2 points and we can still do this the slope formula that we did above, or the slope formula, yeah. Or just do your rise over run. But sometimes we just want to use an equation. Like if we are given an equation and we want to come up with our average rate of change, we'll do something like this. So the average rate of change between 2 points, like point A and B, this could be like 1 and 5 or 2 and 3. Just A and B are some numbers, okay, for like some interval that we want to do. And this is the average rate of change like formula. And it's basically exactly the same. This would still be like your y2, this would be your y1, this would be your x2 and your x1. It's just a different way to kind of think about that, is using function notation. So don't get or worried or anything. It's basically the same. So let's kind of find the average rate of change for this function. F of x is equal to 2x squared. All right, so first let's just have a sketch of it. This is in vertex form where h and k are both 0. So our vertex is right here, and then a is 2. So again, we do like 1a, 3a, 5a, where a is 2, so that would give us 2, 6, and 10. So over 1, up 2, over 1, up 6. And this is what our quadratic would look like, our parabola. Okay? And it says graph the function and use the graph to find the average rate of change over the interval 0 to 2. So on your homework and on your test and reviews, they're going to ask you to do it over an interval. So that's just basically, we want to find out what is the average rate of change when this is like our x1 and our x2. So we'll need to figure out what our y1 and y2 are to be able to come up with our average rate of change. So, but just by looking at the graph from 0 to 2, we can just do rise over run. So at 0, y is 0, and we want to figure out what it is at 2. So this would be our other point, and we could just do rise over run. So 8 over 2, or 4. So the average rate of change over this interval is 4. Now let's do it algebraically. So evaluate the function f of 0 and f of 2. This is kind of like what we did when we did like piecewise functions, except we're just doing one equation. So we want to evaluate when x is 0 and when x is 2, and then we'll write down our ordered pair. So they want us to write it down as a point. So f of 0, okay, is equal to 2 times 0 squared. Well, that's just 0. So our ordered pair here for our first point would be 0, 0, which we already knew because we just saw it there on our graph. But we're just doing it algebraically. And then we want to do it when f is equal to 2. So that would be 2 times 2 squared, or 2 times 4, or 8. So our point here would be 2, 8. Okay, 2, 8. This was 0, 0. And then we'll use like the slope formula to find this, to find the average rate of change. So this would be like your x1, y1, x2, y2, and would do 8 minus 0 is over 2 minus 0, or 8 over 2 equals 4. Okay? All right, so let's do some other examples. We're not going to graph it. We're just going to use the intervals, finding our points, and then doing that, okay? So here we have our interval. This is like our x1 and x2. We want to find the slope between that interval. So we'd want to find like f of -1. That gives you 2 times -1 squared, or 2 times 1, which is 2. Okay. Another way with like this function notation, you can also just say this is like your y1. Okay. So that would be -1, 2 would be our first point. And then for our other, we'll do f of 2, which we already did, but we'll do that again, is 8. So our other point would be 2, 8. That's like our x2 and our y2. And then we'll find our average rate of change. So that would be 8 minus 2 over 2 minus a -1, which is 6 over 3, or 2. So as you see here, again, we have a different slope than we did for the one above. Here it was 4. Now the average rate of change is 2. And it's always going to, like, since it doesn't have a constant rate of change, the slope will always change depending on what your interval is. All right, so let's try this one. We're going to evaluate our function when x equals -3 and when x is equal to 3. So f of 3 gives us 2 times -3 squared, or 2 times 9, or 18. And then f of that's what I meant to have, positive 3 gives us 2 times 3 squared equals 2 times 9 equals 18. So here we have our 2 points would be -3, 18 and 3, 18. And then if we were to use our formula, we'd do, well, maybe we'll label these. Okay, so we'll do y2 minus y1, 18 minus 18, over 3 minus a negative 3, which should give us a positive 3, so that's 0 over 6, or 0. Okay, which kind of makes sense because, well, we did negative 3 to 3, and that won't be on this graph, but if we did something like from negative 1 to 1, our points would be like here and here, and the slope between those two would be 0. Okay, and this other one we went from negative 1 to 2, so that would be like from here to here, and then this would be your slope, where you go up 6 over 3, gives you a slope of 2. Okay. All right, so it's much easier if you graph it, but I won't be providing like graph paper. I'm going to ask you to do it algebraically. All right, here's some others. I don't know that this is necessary to go over if you need to. I guess the difference now is we had a quadratic here. Here we have a linear, and here we have an absolute value function. And then when we get to these examples, we're going to just do it by using the graph. So maybe we'll do this first in case you feel like you're good for the others. So here we're doing the intervals from 1 to 3. So at 1, it looks like it's maybe 2.5. And at 3, it looks like it's maybe negative 1.5. So you could write down your points and do it algebraically, or we can kind of we go down 1, 2, 3, 4. It looks like it goes down 4. And then over here it goes 2. So the slope here would be negative 4 over 2, or negative 2. Okay. All right, and then here's another one from 1 to 3. So 1 to 3. Here, rise over run. It's 2 over 2, or 1. Okay, so like looking at a graph, pretty easy. Okay. All right, so if you wanted to do these ones, feel free to do it with me. If you're good, then get out of here. Okay, so here we have our intervals. This is like our x1 and our x2. And we want to find our y1 and y2. So we'll just evaluate our function. So like y1 is going to be 5 times whatever x1 is, so negative 1 minus 4. And that ends up giving you negative 5 minus 4, or negative 9. So our first point here would be negative 1 comma negative 9. And then for y2, we need to do x2, which is 6. And that gives us 30 minus 4, or 26. So our other point would be 6 comma 26. And then we'll do our slope formula. So here we had our x1, y1, x2, y2, y2 minus y1. Again, make sure if you have double negatives, it will become a positive, but I'll leave that for now. And then we'll do x2 minus x1. So here we'd get 26 plus 9 and 6 plus 1. And that gives us what? 35 over 7, or 5. Here's a quadratic. We kind of already did these before. We'll just do it really quick. So you can pause, give this a try, give C a try before you come back. So y1 here is going to be negative 2 squared plus 5, which is negative 4 plus 5 equals 1. And then y2 is 5 squared plus 5, which is negative 25 plus 5 equals negative 20. So here, you don't really need to write your points. For me, I already have these labeled. So here I would do something y2 minus y1, so negative 20 minus 1 over x2 minus x1. So negative 21 over 3, or negative 7. And then our last example here is an absolute value function. So here's our x1 and our x2. Our y1 is going to be 2 absolute value of negative 8 plus 7 plus 3. So again, absolute values are kind of like parentheses, so we need to evaluate what's inside first. So we'd have the absolute value of negative 1, or 2 times 1, or 5. And then y2 is 2 times the absolute value of negative 4 plus 7 plus 3. Again, evaluate what's inside first. So that gives us 3, or 6 plus 3 equals 9. Okay, so now we'll do our slope formula. So y2 minus y1, 9 minus 5, over negative 4 minus a negative 8, which will give us a positive. We get 4 over 4 equals 1. Okay. All right, well, if you have any questions, please let me know. I hope this wasn't too bad for you. We'll see you later.